All right, today I'm going to show you guys how to transfer units. So you're going to be looking at this as a scale. This is going to be my scale at the top that I'm working with, and today we're working with memory, such as gigabytes, megabytes, kilobytes, and regular bytes. If I want to learn how to transfer something, which is what we're doing the next few days, I have to first create something called a table. Let's say that I have 3 and 48 hundredths gigabytes, and I want to try to make it to a megabyte. If I want to make this from a gigabyte to a megabyte, I have to follow a few simple things. First thing I have to follow is I'm going to make this thing called a ratio table. As I make this ratio table, I'm just going to split my paper like this. Now I want to keep the units on there. It's very important. It's going to dictate how I transfer from gigabytes to megabytes. So this one is going to be my gigabytes, but I want to end in megabytes. To do that, just like I would a fraction, I want my gigabytes to cancel itself out. So I'm going to put that at the bottom, which means my megabytes is going to go at the top. If I have gigabytes on both the top and the bottom of the separation of my ratio table, they're actually going to cancel each other out, leaving me with only megabytes left. The last thing I have to remember is this section right here, these two pieces, this is where my ratio scale comes into play. My ratio scale is going to come into play right here. So I'm going to look, and I'm going to go back to my scale, and I'm going to see, 1 gigabyte is worth 1,000 megabytes. So here's my gigabyte. One of them is worth 1,000 megabytes. To solve this, I'm going to multiply the things on top divided by the things on the bottom. So I will end in megabytes over here. These are going to get multiplied together. Using our knowledge of base 10 multiplication and division, I can actually multiply these without doing any work. Here's how I'll show you. 3 and 48 hundredths times 1,000. 1,000 has 3 circles on it. Zeros. In doing so, every time I take off a circle, I keep saying circle, every time I take off a 0, I'm going to move this 1 place value. Do it again, and I do it again. That means my decimal is going to go right there. Since I am missing a place value, I have to fill that place value in with another 0 to get an answer of 3,480 megabytes.